How do we solve the biggest problems we face? When a challenge is as huge as climate change, we usually assume the smartest play is to try everything at once, spread our bets. But what if that assumption is completely wrong? What if the key isn't doing more things, but doing one single thing with an incredible, almost obsessive focus?
So let's just dive right into this, because a recent paper asks a really provocative question. By trying to build solar and wind and batteries and everything else all at the same time, are we actually accidentally slowing ourselves down? It's a huge question, and it really challenges the foundation of how we've been tackling decarbonization on a global scale.
And at the heart of this is something we can call the diversification dilemma. I mean, think about it. In finance, in our careers, we are always taught that diversifying is the safe move, right? Don't put all your eggs in one basket. But when you're in a race against time, does that same wisdom really hold up?
And this right here, this is the conventional wisdom. We treat the clean energy transition just like an investment portfolio. We buy a little solar stock, a little wind, some batteries, maybe a bit of hydrogen. The idea is that this makes our whole system more resilient. If one tech doesn't pan out, hey, we've got others to lean on. It feels safe. It feels sensible.
But the paper that inspired this explainer proposes a totally different path: concentration. And as you can see, these two approaches are just worlds apart. Diversification, sure, it gives you options, but it also creates this massive complexity. You're dealing with different supply chains, different regulations, different job skills for everything. Concentration, on the other hand, means you make one big bet. And that allows for just radical focus, standardization, and getting your entire industrial base aligned.
Now, this idea of concentration isn't just some theory cooked up in a lab. It has actually been tried before in a super high-stakes, real-world experiment. We're talking about France and their absolutely audacious bet on a single technology.
So back in the early 70s, the global oil crisis just hammered France. Their response wasn't to dabble in a bit of this and a bit of that. No. Instead, they launched what was called the Mesmer Plan, a truly radical strategy to become energy independent by going all in on nuclear power. It was this singular, coordinated national effort.
And just look at this timeline. The speed is absolutely staggering. After that crisis kicked things off, France went from having almost no nuclear power to getting over 75% of its electricity from it in just a little over 2 decades. I mean, that's one of the fastest, deepest decarbonizations of a major economy in modern history. Period.
So, what do we learn from France's massive bet? Well, 3 crucial things. First, that an incredibly fast build-out of really complex, low-carbon infrastructure is totally possible, but only if government, industry, and finance are all pulling in the exact same direction. Second, standardization is a superpower. Seriously, building the same reactor design over and over again just accelerated their learning and made them more efficient. And third, this focused approach can absolutely crush emissions on a huge, system-wide level.
Okay, so France proved this can work for one country. But what if we took that same logic and applied it to the entire planet? Well, the paper asks a fascinating $6 trillion question based on a massive global thought experiment.
$6 trillion. That is roughly how much money the world has poured into renewable energy, mostly solar and wind, just between 2001 and 2024. It is a truly mind-boggling amount of capital.
And that brings us to the core what-if of this whole analysis. What if that $6 trillion hadn't been spread out like a diversified portfolio? What if, instead, the world had copied the French model and concentrated all of that capital into just one single, scalable, low-carbon technology? All right, so the paper actually ran the numbers on this massive thought experiment. Let's take a look at the scorecard and see how these alternate realities would have stacked up against the world we actually live in today.
First, we need a baseline. This is where our current diversify everything strategy has gotten us. Right now, renewables provide about 32% of global electricity. When you add in the nuclear plants we already have, our total share of low-carbon electricity is about 40%, okay? So remember that number, 40%.
Now for the fun part. Let's compare that 40% to the what-if scenarios. If all $6 trillion had gone into just solar, the paper estimates we'd be getting between 9 and 36% of our electricity from it. A wind-only strategy, that gets you between 20 and 52%. Geothermal, if we really focused on it, could have delivered between 23 and 47%. But then look at the nuclear scenario. A concentrated global push could have created a world where nuclear power supplies anywhere from 50 to 90% of all electricity.
And this chart just makes the point so clearly. The bar on the left is where we are today,
about 40% low-carbon electricity. The bar on the right, that's where we could have been in that nuclear concentration scenario, somewhere between 50 and 90%. I mean, that gap between the two bars represents a profoundly, radically more decarbonized world.
When you see numbers like that, you can't help but ask, what does this mean for our future? Does a thought experiment like this suggest we need a completely new playbook for how we think about the energy transition?
So the crucial point here isn't just to pick one technology out of a hat. The paper argues that this concentration strategy works best when three conditions are met. First, obviously, the tech has to be low carbon. Second, it has to provide firm, reliable power, power that's there whenever you need it. And third, and this is maybe the hardest part, you need to be able to align everything, finance, industry, and regulation, all around that single goal.
Now, to be fair, the paper is very clear about the big objections to this idea. A diversified strategy is definitely more resilient if one technology fails spectacularly. We know that in the real world, nuclear power has faced huge cost overruns and delays. Geothermal doesn't work everywhere, and, well, trying to get the entire world to agree on one strategy sounds pretty much impossible. And those are all really powerful counterarguments.
But in the end, the big takeaway here isn't a simple headline, like nuclear is the best. That's not it at all. The real insight is about strategy. It suggests that maybe decarbonization isn't just a technology problem. It's a problem of industrial organization and institutional focus. The real power comes from what we can achieve when we have deep coordination and standardization.
And that leaves us with one final question, one that goes way beyond energy policy. When we're up against an urgent, existential crisis, what's really the better strategy for survival? Is it to hedge our bets and stay flexible? Or is it to pick a path and commit to it with absolute, unrelenting focus?